All right. We're going to cover some more advanced topics in class design. If you haven't already watched the videos about subclasses or the principles of class design, you need to go back and watch those, because all of this is assuming that you've seen the things that I talked about there. The new concept we're looking at today is interfaces. Okay, so what in the world is an interface? Well, here is a very, very basic interface. So let's hit some simple things. You'll notice instead of class, it says interface. And all it has is this one little method here. There's a lot of weird things going on here, so let's just take a minute to absorb it all. So it's public. That's not that weird. Abstract. Okay, we'll talk about that in a second. It's void. So its return type is void. The name of the method is draw, and it has no parameters. Okay, you can have parameters here. This one just happens to not. But the weird thing is it has no body. Okay, it's all header. It has no body. So why? So this is, any abstract method is going to be like this, where it has no body. What an abstract method is, its entire purpose is to be overridden later. Its entire purpose is to be overridden later. So somewhere in a class that implements this, you're going to have a method called draw. It's going to have no parameters, and it's going to have a return type void. So somewhere you're going to see this. Okay, it will be overridden somewhere. Now that draw could look completely different. You know, in one class it's implementing it, in another class, but it all has to have this exact heading right here. And that's it. That's all that this interface does. I'll give you an example of a class implementing that. So here's our right triangle class that I've kind of redone. Ignore this bit in the heading, but in order to implement an interface, you have to say implements this interface. The only thing you have to do to successfully implement an interface is you have to override all of these abstract methods that they've defined here. In our case, we just have one. We have to override draw. So here is my draw method. This is how you draw a right triangle. You'll notice it's void, it's draw, it has no parameters, so it matches up perfectly and overrides this method. Okay. Same with my redone rectangle class. It implements drawable, and we know that it does because it has this right here. So if I run this, it's happy. But let's say I try to run this or compile this without that. It freaks out. Okay, it's like rectangle is not abstract and doesn't override the abstract method draw. Okay, it's saying you said you implemented it, you said you were going to override that method, but you didn't. Okay, and again, normally there's several methods here that it could do. You're still probably sitting there going, who cares? Why would we go through this extra step? What this does is it basically creates a blueprint for, hey, if you want an object to have this certain behavior, it needs to have all of this functionality right here. If you don't implement all of these, it's not going to be able to get the job done. And basically what you want is, you want it to fail here if it's not implementing all of that, so that later you can say, hey, I want to draw this. And if you say draw, it, no matter what object it is, as long as we know that it implements that, we should be able to draw it. Okay. it's that polymorphism we talked about before, where I can just say the word draw and it means lots of different things, but I know that I have access to that draw method for anything that implements drawable. Okay, so let's fix this and see what this would look like once we actually start using this. So I made this class draw tester. I made a right triangle object, a rectangle object. It has colors now. Don't forget about that. That's for later. I also made a drawable object. Now you'll notice there is no constructor on drawable, but you can construct a drawable object by using a class that implements that. So I can make a right triangle object and store it as a drawable object. Now, the downside there, depending on how you're looking at it as far as upside, downside, is it's only going to have the behaviors of a drawable object, which in this case, the only thing I'm going to be able to do with it is draw it. Okay, or if it had like several things here, those would be the only things we can do. I'm not going to be able to get the perimeter or get the area because it is not a right triangle object anymore. It is a drawable object. Okay? You're still not sure why we're doing this. Let's look at this right here. So I'm making a list of drawable objects called draw list. Okay, I'm going to make an array list here. By the way, I'm going to explain in a minute why I said list and not array list. So now that I have this, list, I'm going to add right. Well, right is a right triangle. Is it drawable? Yes, it is considered a drawable object, so I can add it to this list. Rect, yes, it's a rectangle, but it's also a drawable object. Again, a thing can be multiple things. Draw is a drawable object by name, so I can also add it to the list. So I have this list, and it's got right triangles, it's got rectangles. Theoretically, we could have circles, and we could have all these different things. Well, if it's a drawable list, what should I be able to do with all of these? Well, I should be able to draw them. And that's what I'm going to do. I'm going to loop through this list, and I'm going to draw them. Okay, so I've drawn all of my objects. Don't judge my horrible triangles and rectangles here, but that's the key, is that we're able to do this action that has the same name, but looks different depending on how it's being implemented.